What is a register? Register memory is it's nothing but smallest and fastest memory in a computer. It is not a part of the main memory, and it is located in the CPU in the form of register, which was the smallest data holding element. So as we have the idea of memory till now, that what are the memories and why we use those memories. So the main reason why we are using this memory is also the same, to storing the data as well as to cope up with the speed of the CPU, right? Any register temporarily holds frequently used data, instructions, and memory addresses that are used by the CPU. So as this register is a memory which is inside the CPU, and it will help the CPU to store the frequently used data, instructions, and memory addresses. And it is very much essential for a CPU to get all these data. They hold instructions that are currently processed by the CPU. So yeah, that is currently processed by the CPU means if a CPU has just processed the data, so that data also has to be stored in any of the register. All data is required to pass through register before it can be processed. So all data, wherever we want to give it to the CPU, it has to be there in the register. They are used by CPU to process the data entirely by the user. Register hold a small amount of data, around 32 to 64 bit. The speed of CPU depend upon the number of size of the bits of the register that are built on the CPU. So whenever this we find out that the size of the register is more than that amount, so definitely that CPU will become more faster. Register can be of different type based on their uses. Some of the widely used register include accumulator, that is called AC, data register, that is called DR, address register, it is called AR, program counter, that is called PC, IO address register, and more. Now after that, there are different types of register. What is the first register? Is the data register, where we store the data by which we do the operations. Program counter, it holds the next address of the instruction, next instruction address, and it is there in the memory, so that it will store the memory location of it. Instruction register, here it will hold the instruction which it is going to fetch from the main memory, so that instruction has to be there in the instruction register. Then we have accumulator register, in which whenever the CPU will process anything, that process data will be stored in the accumulator register, AC. Then we have the address register. It will hold the address of the instruction or the data. Then we have IO address register. This is attached with the any IO devices, input output devices, and it will hold the address of that particular device. And then there is a buffer register. So whenever the data will be sent to that particular and it is required by the IO, so that is stored in this buffer register. Okay. So yesterday I have given you one glimpse or one example of how these memory, this registers will work actually. So I'll explain that example again today so that you can understand it very deeply. So all memory that we are talking about here so we are talking about two type of memory. One is the main memory, another is a register. Register is as we know that it is inside the CPU. Okay, so let's talk about first the main memory. So we have a main memory exists with us, and this main memory is of 4096 into 16. This is the size of the main memory. So main memory is nothing but your RAM. Okay. And what is the 16? 16 is nothing but the word size. So operating system deal with the word. And as we have discussed in last few classes, that there is a smallest uh, what the smallest structure is nothing but the bit. Then 8-bit will become byte, and then we are talking about word. The word is here of 2 byte. You can see, because it is a 16-bit word, it means it is of so it is of 2 bytes. 1 byte is 8-bit, right? So, and this word is used by the operating system, and how the operating system is based on that, this word will be increase or decrease. Okay, now let's draw the main memory that we have. Let's say we have the main memory exists, and in this main memory, there are 1096 locations where in each block 16 word can be accommodated. So we'll like put like that so that you can understand that there are a bunch of blocks, and in each block we have 16 bit of data exist. And how we can differentiate between the addresses. So we can differentiate between the addresses with the help of 4096. So 4096 we can represent with the help of 2 to the power of 12. It means that each and every memory location of the block could be represented with 12 bits. So let's say for this we have 000 up to 00, means this is of 12 zeros. This is one memory location. Then we have, this is 01. This is the first, this is the first, this is the second memory location. This is the third memory location. And this is the fourth memory location. And in that way, this addressing will go on. Okay. This is about addressing. And here we have word of 16 bits. So here the size of this will be 16 bits. This is the size of this one block. Now let's talk about different type of registers that we have. So the first register that we have is address register, that is also called AR. What is there inside the address register? Inside the address register, this address value will be there of any of the instruction that is there in the block. Okay, and each block we have some sort of instructions or the data, right? So for instruction or the data, this address register will hold the address of that particular memory location where it will get, the CPU will get the data or the instruction. Because in the von Neumann architecture, we know that instruction and data should be resided inside the main memory. So it is inside the main memory. So what should be the size of this particular address register? Because it will hold the address of this particular memory. So it will be from 0 to 11, it means it is of 12 bits, because with the help of 12 bits, we can represent one address here, right? So it is of 12 bits. Next, we have data register, DR. In the data register, we'll store the data which we are fetching from any of these blocks. So definitely, if we are fetching the data, it should be of 16 bits, because we are fetching from the blocks. So the maximum size will be of 16 bits, 0 to 15. It will be of 16 bits. Next register where we have is program counter. That is also called PC. What is that program counter? Program counter will hold the next instruction address. Let's say here we have fetched the instruction I1. Instruction I1 we have fetched previously because the address was there. After that, what will be the instruction after that? So there is an instruction I2. And what is the address of this instruction I2? This is the address of the instruction I2. So this address will be held by the program counter. So because it is holding the address, the size will be of 12 bit. This is your program counter. Then we have another register which is called accumulator, which is, in short, we say AC, accumulator. This is called accumulator register. What is the size? What it will do? Accumulator register will hold the result generated by the CPU. If CPU will execute any instruction, that result will be stored in accumulator register. So definitely it will store some sort of data, and data size is of 16 bit. So it will be, the addressing will be 0 to 15. It means it should be of 16 bits. Now, after that, we are talking about another special type of register, which is called instruction register. This is called IR, instruction register. What is this instruction register? Inside the instruction register, we should have the instruction. How it will be divided? It will be divided into 3 parts. So the first part is your which type of addressing we are using. So it is talking about addressing. To fetching the instruction from the memory, what type of addressing we are using. The second part is of the operand. What is the operand? It is of, so it is of 1 bit. Operand is of 3 bits, and the rest of this is the address of the data. So it is nothing but this. Okay, this is not the operand. This is actually the opcode. Opcode means your operation code. Okay, so I'll write it here. Opcode, some sort of operation. Then we have operand here, or the variable or the data. So I'll write data, or we can say it is a operand. This operand will be here, and not operand actually, the address of the operand will be here. It is of 12 bits. So in the instruction register, the total size will be from 0 to 15. It is of 16 bits. And this opcode is of 3 bit. In the opcode, what will happen? In the opcode, we have some sort of operation, like let's say if ALU have the instruction called multiplication. So we have a multiplication operation here, or it will want to do some sort of addition. It should have an addition operation, subtraction operation, or division operation, or mod operation. Whatever operation it is doing, we can represent it with the help of 3 bits. So actually these are stored into the memory. So it has again 3 parts. You can see this is your either 0 or 1. So this particular part will be either 0 or 1. 0 will be your direct addressing and 1 will be your indirect addressing. So what is, if we are making a direct addressing, means if we are making it 0, let's say the opcode is addition and there is some memory location which is written. Let's say 450 is your memory location of the data. So once we'll go here, we'll read 0. In that, we'll find it out that it is a direct address of the data. So let's say this is your 450 location. Let's assume that this is your 450 location. You convert it into a decimal. Okay. So yeah. So the instruction will be read here. It will be stored in the instruction register, and then it will go to the address of it. That address will be fetched here, and it will go to the address of it. So here we'll find out the data. Let's say the data is a, some sort of variable, and the value is there with the a. What happened in the indirect addressing? Let's say we have an indirect addressing, and this indirect addressing will be represented with 1. Okay. And let's say we have an operation of multiplication, and we have the address of, let's say, 550. Let's assume that this is your 550 location. You can convert it into some sort of binary addresses. Now, when it will go from here to here to get the data, it knows that here also will not get the data. Here it will get the address of it. So it will go to the address of it. Let's say the address is 120, and here it will find out, let's say, 120 location. So now from here, the control will go to that particular place, and here it will get some sort of data. So this is how your instruction register work, and we have the instruction on it. Okay. In the detail, you will learn about the addressing. You will learn about learn in computer organization and computer architecture. Now after that, we have some register for the IO devices. Okay, that is called IO register. One register is your IO address register, and another will be your IO buffer register. Okay, so generally it is depend upon again the architecture of the CPU. It is of generally it is of 8-bit, because when we get the instruction uh, from the keyboard and all, will use to take one character. So one character we can represent with 8-bit. So this is how your whole register is there, and this is how it is working.